a principal engineer at Skylab. He will be talking about the Zero Trust architecture from the API developer perspective. Thank you.
Hello everyone and welcome to API Days Connect Hong Kong 2023. For this next session, we are going to talk about the Zero Trust architecture from an API developer's perspective. I am Dipin Behl and about 17 years of professional experience in designing and developing digital solutions in multiple domains. I'm a principal engineer with Striker, based out of the Striker Global Technology Center in India. We're going to begin today with my favorite quote to make everything as simple as possible, but not simpler. This has become the de facto principle of everything I design and help me bring really useful products to market. Today, we're going to begin by asking ourselves that what exactly is zero trust and what this fuss is all about. Then we will ponder over why do we actually need it, and then most importantly, how do we implement the zero trust architecture in our API infrastructure, no matter if you're a small scale, a mid scale, or a huge scale enterprise. Finally, I would like to end with, so now I know I'm a bit more wiser about the zero trust architecture. So diving straight away into our very first question, what is zero trust architecture? So post-COVID, the world has got a lot more remote and distributed than it has ever been. This means that the usage patterns and requirements have also evolved, and we as API developers must adapt to this change. The concept of zero trust architecture is not something new. In fact, it has been proposed quite a while ago by the US Department of Defense that we move away from a holistic security implementation to move focus to individual security requirements. This forms the core of zero trust architecture to never trust and always verify. You look at this infographic here, which talks about the four basic quadrants of a zero trust architecture. These are pillars of zero trust. These components are to be treated individually and come together to form a single system. They have varied needs of security around them and should work in cohorts to form a secure ecosystem. We as developers are part of each of this quadrant since we respond to different devices carrying different identities, connecting with different applications, which present the data and is hosted on the API infrastructure. This is a collective target, and we API devs should also be playing our part in the ecosystem. Now, there are three major principles of zero trust security, and the first one of which is to verify explicitly, which means that we must verify all aspects of an incoming request, such as the device it originated from, the identity it bears, the network it comes from, the endpoint it's targeted to. After looking at all this information, we must apply our threat intelligence to see if we really need to serve this request or not. Once verified, we must apply the principle of least privileges, which ensures that only the rights required to perform this action has been granted to the request. These rights must also be granted for this particular request and should be reevaluated for the next incoming request, even if it comes from the same device, identity, or network. This dynamic evaluation should be done for each session lifetime. Finally, the zero trust asks us to assume that there is an active breach in the system. This means that we assume that every resource around us has been compromised, and we must protect this one by minimizing the lateral movement and controlling the blast radius. As best practices of zero trust architecture, we must always assume that everything behind the corporate firewall is not safe. Now, we've been creating microservices in our APIs, but there must be a defined microsegmentation policies on how they can communicate and trust each other. Again, minimizing the lateral movement between these microservices can help contain the blast radius in case of an actual breach. We must also monitor the activities closely and apply some tools on top of it or as a sidecar pattern so that we can quickly identify and maybe even respond to the anomalies. Also, the protection of identities is important, and we can do that by providing additional verification measures such as MFA. All right, now let's have a look at why do we actually need zero trust security. So perimeter security has been around since inception of APIs and it has served us well till now. It is still an important part of the overall ecosystem, and zero trust should not be looked as a replacement of perimeter security, but rather as the evolution of security practices. Let's look at an example here. So traditionally, we had an API ecosystem and we would build a wall around it, which has our firewall and other network security. This builds a parameter, a dematerialized zone around which and within which we assume that everything is trusted and has been secured. Now assume this parameter is breached and a bad actor is able to penetrate through it. Since the defenses inside are not that solid, the bad actors such as a ransomware can affect other parts of the overall system. It is much like how Greek soldiers took down the city of Troy using the Trojan horse. As an evolution, we could segment our resources into, let's say, computation and file storage and create different parameters around them. That is still better, but we would now be building bridges and tunnels between them. So zero trust takes it a step further to say that let's recognize each one of them as an independent resource and build security practices best suited to each type. One parameter security focuses on defining a trust zone and considers that everything inside it is secure. Zero Trust asks us to move defenses from static network-based parameters and focus on users, assets, and resources. This allows us to dynamically include different components in our API ecosystem and apply the defined policies on top of it. These policies are then evaluated and strictly enforced during runtime. Also, these policies must be periodically reviewed and tuned based on the user's data. This helps us better the overall security posture of our API ecosystem. Now comes the most important question of how do we actually do it? I frequently get asked how to bring the security model to my API ecosystem. I always say that we should begin by defining the policy to establish the trust between the components. The trust authority can be centralized or non-centralized based on your requirements. Basic rule behind establishing a trust authority is to define a protocol which all participating components must abide by. The ultimate purpose is not to deny the request, but to allow every request that generates from a trusted device at a valid identity and acts according to the defined rights on the allowed data. This means that all the four pillars of zero trust participate to form a valid action. Now, there is not a one size fits all theory behind it, and depending on the scale and the purpose of your API, you may choose a strategy. It may vary for a small or a mid-scale API to an enterprise scale API, and may also differ on the technology landscape behind it. According to your needs, you can plan for a hybrid mechanism with multiple topologies to choose what works best for you in defining the trust policies and establishing your trust authority. One of the most common and the already evolved industry standard is to use open authentication. It is an open framework which most of the web-based APIs are already leveraging. This is very useful when there are unrelated servers in the API ecosystem or have multiple microservices, some external components. We call it open authentication because the format it uses is generic in nature and also human readable. The asymmetric cryptographic keys are used to establish the trust between the individual components, and the OAuth servers act as the central trust authority. It provides the client with a JSON object which contains the client's claim on the resource, which is then signed by the central trust authority using its private key. The JSON object is encoded in a base64 as a JSON web token and is contained within the client itself. The central authority is also responsible for maintaining the lifetime of this token of trust. The same way, a participating open identity provider adds the identity of the client to the JWT signed by the same private key. Whenever this token is presented to an API component, it verifies the true nature of this token using the public key. Once the signature is verified, it proceeds to check the other aspects of the token and make sure that everything is in place before providing the access to the resource and data. This evaluation happens for every incoming request, and zero trust is assumed between the client and the resource. Now let's take a look at the security workflow and how the trust has been established with an infographic. The client or the process presents its credentials to the participating identity server. The identity server provides a token to the client, which is then presented to the authority server. Now, both servers have pre-established a trust among themselves, as the identity server's public key is already known to the authority server. Once verified, the authority server proceeds to provide the client with an immutable token. Since this is open in nature, you can view the identity claims but cannot modify them, as it has been signed by using a private key. This token is then presented to the resources with every request. When the resources verify its signature using the already known public key and all the other aspects contained in the token. Here, the trust is also pre-established, and because the public keys are actually shared with all the components within the API ecosystem. And this is how OpenAuth and JWT actually leverages the zero trust architecture. Now, another way of doing it is by using managed identities. This mechanism works better for enterprise level APIs where there's a well-established IAM system such as Active Directory. The identity and the access management systems play the central role of a trust authority in this topology. They identify each component in the enterprise and assign a unique identity to each one of them. Some cloud providers even allow you to provide your own custom identities to these components. These IAM systems have matured over time and are mostly battle hardened to uplift your security posture. Once the identities have been assigned to the components, the rights are then assigned to these components on other resources in the same IAM system. These RBAC or role-based access control help categorize the resources and apply similar type of controls on them for better governance. They define what access which entity has on what resource. For example, you may configure one of your computation service to have read access only on your cloud-based file storage. This is now baked into the IAM system as a template, and then other similar cloud services can follow the suit to prevent any misconfigurations. Also, this would allow us to dynamically and automatically onboard other components into our API ecosystem. These IAM systems help better enforce the policies and can actually provide a holistic view of your API security posture. A lot of these smart IAM systems include log monitoring to automatically detect any intrusions and may even respond to them. Let's look at the security workflow of a zero trust API using either Azure Active Directory or AWS IAM as a central IAM system. The features like Azure's AMSI are important to this implementation. While we use our Terraforms or ARN templates or CloudFormation to define our cloud infrastructure using infrastructure as code scripts via the DevOps pipelines, we can assign the identities to these various managed services we create or ask the cloud provider to do that for us. This would register them as uniquely identifiable and are tenant of the IAM system. Again, using the same infrastructure as code scripts, we can then define the access of these services on other services. For example, while you create an Azure function and an Azure Managed SQL Server instance within your microservice setup, you can assign the Azure function an identity and then assign this identity to have execution rights on the SQL database. This way, you would not have to include the password to your SQL Server in your Azure function configuration. How cool is that? Given that we've always been worried about hard coding and leaking those credentials in the past. Now, this also reduces the chances of misconfiguration from a human error. Another example, we can also within the same DevOps pipelines define the access of a user identity to a particular network or part of that API without having to bake that in within our code and application. IAM systems also come in handy for maintaining the device-to-device access of the enterprise resources. Beside all this configuration management and enforcement, the modern AIM systems based and distributed by major cloud providers have smartness built in. They periodically scan your environments for compliance and monitor the usage patterns. They flag any resource which is not in compliance, resulting in highlighting of a resource which may potentially have misconfiguration and might have gone undetected. Another typology of establishing the trust is mutual TLS, which for me is possibly the most exciting of them all and probably the newest trade on the block. This takes advantage of the TLS and SSL workflows that we have all become very used to till now. This is best suited when all the components are owned by the API ecosystem and there are small custom defined IoT devices acting as clients. Though it can be extended to any usage by setting up a private key infrastructure. A certification authority acts as the central trust authority, which can be self-established or a global root certificate such as DigiCert can be used. The certification authority is part of our custom private key infrastructure, is responsible for issuing a certificate with the required object identifiers or OIDs to all the components. It also defines the validity of the certificates and may revoke or extend the certificate based on the component's lifecycle. The usage of asymmetric keys allows participating components to identify other components in the ecosystem using the private key and public key paths. When new devices or components want to join the ecosystem, they can issue a certificate signing request, which is with the certification authority, which then sign using its own private key. But the biggest advantage that this topology brings to your ecosystem is the ability to mutually encrypt data and transition using session keys, which they can generate using zero knowledge proof algorithms. Mutual TLS is more of an encryption and identity management protocol than it is for rights management. Looking at this with an example, the first thing that we would require is a private key infrastructure that contains a root certificate for the certification authority. This PKI now becomes a central trust authority and issues a certificate using which the components identify and establish trust with each other. This uses the already established rules of transport layer security and allows us to quickly reject the request which do not originate with a correctly signed certificate or does not have the required object identifier attributes. Now, if a device or a component is to be added to the ecosystem, it would generate a certificate signing request with the desired identity and send that over to the certification authority. If the information is deemed fit by the certification authority, it will send back the signed certificate to the component. Now, this component is ready to interact with other components in the system. But as an added advantage, the components of the system, if they have the correct the OIDs, they can use this to generate session encryption keys using zero knowledge proof mechanisms and encrypt the data end to end. And this data is not readable by any component of the entire system. Now, I hope that by now you understand what the basics of zero trust security are and why do we need to incorporate them within our API ecosystem. More importantly, I hope that you feel more confident on designing your own strategies to implement zero trust in your API ecosystem. Before we end, I wanted to put forward some more thoughts on the zero trust security. We must embrace that the zero trust is not a target to be achieved and then relax. In fact, it should be a practice to be incorporated when enhancements to the API are designed. Setting up the protocols early is important, and we must adhere to them as new features or components are planned. It is a collective responsibility, and more functions should be included when the transitions are planned. We must also remember to not reinvent the wheel when we transition over our APIs to implement zero trust security. There are already well-established tools, both proprietary and open source, and practices in the industry that you can leverage. We must plan the journey rather than shooting for the moon. Also remember that security information and event management tools and the security orchestration, automation, and response tools are your best friends in this journey. These tools use much evolved artificial intelligence to detect early anomalies. We need to begin with introspecting our login cadence and connect that with the SIEM tools. While they detect an intrusion early or an attempt to intrusion early, the SOAR tools then come in handy when we plan for an automated response to it. Your SOC operation teams is going to love you if you have that as a sidecar to your APIs. And finally, evolve. The industry is setting up standards and best practices and maturity models around the zero trust, and we must stay in the know. Non-commercial organizations such as NIST, CISA, ISO are putting in efforts to give the standards a shape. That's it today on the Zero Trust Architecture from me. I hope you find this part of API Days Connect useful and continue your journey to a better API. You can connect with me on my social handles. Till then, happy coding.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.